Coral reefs are vibrant underwater worlds home to fascinating creatures like clownfish, seahorses, and jellyfish. But these ecosystems are at risk due to climate change and pollution. Protecting them means preserving ocean life and balance. Let's explore, admire, and safeguard these underwater wonders.
Coral reefs are among the most diverse and valuable ecosystems on Earth, providing habitat for countless marine species, including clownfish, jellyfish, and seahorses. Recent research has highlighted both the challenges these ecosystems face and the innovative strategies being developed to ensure their survival. Artificial light disruption. A study published in December 2024 revealed that artificial light can significantly disrupt nocturnal behaviors of reef inhabitants. The exposure to artificial illumination wakes sleeping fish and attracts predators, thereby altering the natural dynamics of nighttime coral reef communities. This finding underscores the importance of managing light pollution in coastal areas to preserve the integrity of reef ecosystems. Strategic coral placement for conservation. In January 2025, researchers discovered that the survival rates of rare elkhorn corals in Florida could be enhanced by placing them in shallow waters with fast currents. This strategic placement leverages environmental conditions favorable to coral health, suggesting that targeted conservation efforts can bolster coral resilience against environmental stresses. Symbiotic relationships, enhancing resilience. A study from mid-2024 highlighted the symbiotic relationship between damselfish and corals. Corals inhabited by these tiny fish were more likely to withstand and recover from heat waves. The damselfish contribute essential nutrients through their waste, effectively fertilizing the corals and enhancing their resilience to temperature-induced stress. Genetic research and supercorals. As global warming continues to threaten coral reefs, scientists are racing to develop supercorals capable of surviving in warming seas. The Wellcome Sanger Institute-led Aquatic Symbiosis Genomics project is sequencing coral DNA to better understand and enhance their resilience to rising sea temperatures and diseases. This research aims to pinpoint symbiotic partners and utilize genetic editing to create more resilient coral species. Innovative restoration efforts. In the Mediterranean, organizations like Ocean Quest France are actively engaged in coral conservation and restoration. Using eco-friendly methods, they replant coral fragments on natural substrates to foster recovery. Despite challenges posed by climate change and marine heat waves, these efforts have demonstrated measurable successes, highlighting the potential for human intervention in coral conservation. Discovery of massive coral colony. In the Solomon Islands, researchers have discovered an enormous coral colony, roughly the size of 2 basketball courts. Identified as Pavona clavis, this coral measures 34 meters wide and 32 meters long, and is estimated to be several centuries old. Its resilience to environmental stresses offers potential insights for conservation efforts, as it may help repopulate damaged reefs. Corporate involvement in coral restoration companies like Mars Inc. have become global leaders in coral reef restoration, having planted more than 1.3 million corals over 15 years. They have developed scalable solutions, including reef stars, hexagonal steel structures that aid coral recovery. Significant improvements have been observed in areas like Indonesia's Hope Reef, demonstrating the impact of corporate involvement in conservation. Conclusion. These studies and initiatives underscore the complex interactions within coral reef ecosystems and the multifaceted approaches required to protect them. Through a combination of strategic conservation efforts, genetic research, innovative restoration techniques, and corporate involvement, There is hope for preserving these underwater wonders and their diverse inhabitants for future generations. Recent research has provided deeper insights into the diverse sea creatures inhabiting coral reefs, particularly focusing on clownfish, jellyfish, and seahorses. Clownfish and sea anemone symbiosis. The mutualistic relationship between clownfish and sea anemones has been a subject of extensive study. Clownfish find refuge among the stinging tentacles of sea anemones, gaining protection from predators. In return, clownfish offer several benefits to their hosts. Nutrient provision. Clownfish waste is rich in ammonia, which fertilizes the anemone, promoting its growth and respiration. Enhanced water circulation. Clownfish perform a characteristic wiggle dance, increasing water flow to the anemone. This behavior aids the anemone's respiration by facilitating gas exchange. Protection from predators. Clownfish actively defend their host anemones from potential threats, such as butterfly fish that prey on anemones. However, climate change poses significant challenges to this symbiotic relationship. Rising sea temperatures and ocean acidification can lead to coral bleaching, adversely affecting both anemones and their clownfish inhabitants. Research indicates that clownfish are particularly sensitive to environment.
Harnessing community science for seahorse population monitoring, insights from the Seahorse program in Tampa Bay.
The new study highlights the value of community science for seahorse monitoring and conservation. Harnessing community science for seahorse population monitoring, insights from the Seahorse program in Tampa Bay, in aquatic conservation, marine and freshwater ecosystems. The study showcases the important role of community science in monitoring seahorse populations to support conservation efforts. This research was made possible through the partnership between Project Seahorse, a global marine conservation team, and Tampa Bay Watch, a non-profit organization in Florida, USA. Tampa Bay Watch led a 5-year community-driven initiative to monitor 2 local seahorse species, the lined seahorse, Hippocampus erectus, and the dwarf seahorse, Hippocampus zosterae. These efforts are ongoing and are part of iSeahorse, a global citizen science program in the iNaturalist family. The iSeahorse empowers divers, snorkelers, and marine enthusiasts to report seahorse sightings and contribute to conservation research. Seahorses are particularly suited to citizen science because they are charismatic, sedentary, and live in shallow water. The findings from Tampa Bay did 2 things. They matched well with available scientific data, adding to our confidence in citizen science, and filled important gaps in knowledge needed for conservation. For example, data reported in this paper provided new insights into seahorse population trends and reproductive behaviors, including an extended breeding season and the first recorded body lengths for the dwarf seahorse.
Thank you for watching. Please like, share, and subscribe the channel.